All right, we're going to talk about organic chemistry this week, just an introduction to organic chemistry, because the other teacher and I figured that this would be a good little bit of taste of organic chemistry for these 4 days before spring break. And then we'll be coming back to organic chemistry later on in the year. We're probably not going to go to finish organic chemistry after break. We're going to do a different topic. But this is relatively easy stuff for you to understand, so we figured we'd do something that was kind of like simple for this week. All right, so when you think of organic chemistry, a lot of people think, well, organic, they think of these types of pictures, right? When you think of organic, it's on the Google Meet too, if you're in there. Are you in there? I could go. But organic chemists, when they think of organic chemistry, they think of these symbols right here. All sorts of different types of compounds. There's specific types of compounds that are called organic, right? And what makes an organic compound? Well, organic compounds, every single organic compound that you encounter will have a particular type of element in it. And that element is carbon. So here's what carbon looks like. We are using the bonded carbon. That's why I have crossed out the unbonded carbon picture on this slide. So a carbon is very versatile. It can bond to many other atoms of itself and also to other atoms, obviously. So you'll often find that organic compounds also have hydrogen in them. This picture right here is the simplest organic compound, methane. You may have heard of methane before, right? So carbon and 4 hydrogens attached to it. Carbon has 4 bonding sites, and the picture at the top is supposed to show you that the atoms that they bond to fit into the corners of like a box, if you were to put a box around carbon. Okay? Now, there are certain types of organic compounds. You can have single bonded organic compounds, single bonds between the carbon atoms, or double bonds, or you can even have triple bonds. And you can have closed chains as well. It can form full loops. The most simple type of organic compounds are called alkanes, a family called alkanes. They only have single bonds in them. And they're also called hydrocarbons because they've got hydrogen and carbon in them. If it's a hydrocarbon, it only has hydrogen and carbon in them. I have some models over here that can demonstrate this stuff a little bit. Okay, so methane, if you look here, has 1 carbon atom in it. Ethane has 2 carbon atoms in it. And let's take a look at how we know how to name these. So if it's a single bond, these are called alkanes if they have single bonds. And we're going to go to our reference tables. Oh, I have to remember which one it is. Is it R? Nope, it's the one before it. Or is it Q? Okay, so notice this says alkanes have single bonds in them. And so we're going to actually open another one, the one before it, P. If you have 1 carbon atom in an organic compound, the word starts with meth. So that's why this is methane. Okay? And there's only single bonds in it, so it's an ane. It ends with the word. What's that? Okay, that's a different type of meth. But anyway, so this ends with ane. And so if we have 2 carbons, like I said, this is ethane. Notice that there are 2 carbons. If there's 2 carbons in it, and I can show it to the people at home, this is 2 carbons in it, so this is called ethane. Okay? And it's only got a single bond, so it's ethane. So let's say I were to draw, what would be the name of this compound. Now here, let me get it for you. I'm not going to put the C's on it right now or the H's on it because that just takes a lot of time to write all the H's. But just realize that there are H's at the end of each of these hydrogens, okay? All right, and this is a common way to write it, shorthand for it. So what is the name of this compound? Use your reference tables. Pentane, right. So we go over here, we see that there's 5 carbon atoms. So it starts with a pent. Oops. Oh, man, come on. Pent has only single bonds in it, and so it's an alkane. It belongs to an alkane, and so it's going to be called pentane. Right? So that's pretty simple and straightforward. And on this other, oh, that was it. Okay. On here, we can see all these going from all the way from 1 carbon atom to 10 carbon atoms. So methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Fortunately, you don't have to memorize it, but you could. Yes.
There's like in this thing also that they go through like 2 lines instead of only 1 union.
No. Okay, so now if we look at this table here, we're going to see that we have a double bond right here. That's what you're talking about, right, Andy? Yeah, so the double bonds, they belong to the alkenes. So in this case, this is called, because we've got 2 carbon atoms, again, we're going to, let's take a look at that. 2 carbon, it starts with F, but now we call it ethene. So that would be, notice that there's less bonding sites. Carbon can only have 4 bonds coming off of it, so there's less hydrogen. This is called ethene. All right. Let's do another one. What would this one be called? This is called propene. All right. Now, we could have this. Oh, this is a little trickier. Not trickier, but a little different. There is this compound. But there's also this compound. Or this compound. Look at, I've put the double bond in different locations, right? So now what we need to do is figure out how to distinguish between these different ones. Because since we have different locations, we're going to have to describe them slightly differently, right? Okay, so what we do is you number the carbon atoms so that and you'll see in a second, 2, 3, 4. All right, these carbon atoms are numbered. And I'm going to call this 2. No. It says 4, so I'm going to show you. This starts with a bute. Okay, so this is 2-butene. All right. Now this next one, because it's coming off of the 2 carbon. You choose the number that is the lowest. All right. Now let's number these. 1, 2, 3, 4. What do you think we call this one? Yep, this is going to be 1-butene. How about the last one? What do you think we call that? You'd think we'd call this 3-butene, but guess what? This is also 1-butene. And the reason is that you could take that molecule and you could just rotate it around and it would become the same thing. So it's exactly the same molecule. So when you choose to number your carbons, you need to start from the side that will give you the lowest number. Okay, so we would number it from right to left in this case.
Would 2 and 3 be the same? Since when you turn it?
Yes, so we would just call it 2-butene. There is no 3-butene and there's no 4-butene. It's only 1-butene and 2-butene. These are called, would these be isomers? I guess they kind of would be. These are called isomers of each other because they have the same atoms and molecules, but a slightly different structure. Atoms and molecules. They have the same atoms, but a slightly different structure. Okay, so, and then the last type of the last type of what they call the homologous series of hydrocarbons is these alkynes. So the joke is that it takes alkynes to do chemistry. And so we can go ahead and let's make a let's do a compound. So how would we, so notice that these carbons now cannot have any hydrogen atoms attached to them because they have 1, 2, 3, 4 bonds already. Okay, so what is the name of this? Let's count our atoms, our carbon atoms. We have 6, so we're going to start with hex. So this is a hexene. Hexine, because it has that triple bond in it. But we need to tell what number it is because we could put that triple bond in several different locations, possible locations. If we number it from the left to right, the number is going to be greater than if we number it from the right to left. So we're going to say this is 1, 2, 3, 4, 5, 6. And so this is going to be called 2-hexine. Okay. And you'll notice that on this homologous series that there's a certain type of formula that represents these these structures. So N is just the number of carbon atoms, and then you use that N to determine the number of hydrogen atoms that will be in that compound. And it says that right there at the bottom. Okay, so there are some multiple choice questions for you too.